Hello, everyone. So, presentation I'm giving today is called Crypto 2.0, a State of the Onion report. So, just because I'm historically not particularly good at openings and conclusions, I'll probably get straight to the point. So, start off, why Crypto 2.0? So, people talk a lot about Bitcoin, people talk a lot about blockchain. I quite often end up sort of talking about crypto instead. And I do this deliberately. So the reason why I do this is because I think that, even though blockchains are a very large part of the point, they're not the entire point. So in general, there's this entirely large set of projects, things like IPFS, this distributed file storage project from Juan Baptiste-Benet out of New York. There's Monetas, a company based in Switzerland, which is doing client-server-based cryptographic finance. There's a lot of interesting research being done around zero-knowledge proofs. There's people looking into distributed hash tables, and an entire sort of long list of these new technologies that are sort of philosophically, ideologically, I think really in the same space as what we're trying to get at. They're all sort of supporting sort of very similar kinds of values: decentralization, empowering individuals, taking out the middleman. Basically all the same things that we care about. But if you had to just be a pedantic prick about it, the fact is they're not blockchains at all. So at the same time, there are things that we care about. So I think it's important to also sort of think about the space as being broader than, just the space of technologies based on pieces of data that contain hashes to previous pieces of data containing hashes to previous pieces of data. So, it's about the use of decentralized cryptographic and trust minimizing technologies to improve, freedom, cooperation, equality, fraternity, efficiency in our lives. So, next question, why onions? Because blockchains are like onions. Blockchains have layers. So, this is not just me saying it, this is basically just about everyone saying it. Apparently, in the past 5 years, we've moved from blockchains simply being a peer-to-peer system for moving money around to this sort of incredibly complex architecture where you have different kinds of blockchain protocols, then you have different kinds of networks sitting on top of them. You have reputation systems, smart contracts, data feed oracles, side chains, tokens, different kinds of financial architectures, exchanges, interfaces, applications sitting on top of all of them. And it's turning into this sort of application stack that's basically pretty much as complex as what we have for something like web applications on the internet. So, next point. This is what the blockchain's crypto whatever space was like back in 2011. So fortunately, this is the one industry where I can claim to be a veteran that has more years of experience than almost everyone else who's probably even here, much less in the mainstream. But back when this industry was really starting, it was this sort of motley collection of people doing things like selling alpaca socks, gambling, selling food for Bitcoin just because people like food and people have Bitcoin, so you might as well make a mutually beneficial transaction, Pareto improvements or whatever, and of course the other kind of Pareto improvement people care about, which is whatever it is Stripcoin does, I don't even know. So this is where we are now. So we have banks doing experiments on blockchains. We have Microsoft, implementing Ethereum, allowing people to spin up Ethereum nodes on their cloud services. BitNation has a partnership with their e-residency program which is part of the government of Estonia. NASDAQ is doing blockchain experimentation. So, we've made a few small steps since this. Yeah. So what's the point? So, why are blockchains useful? Why is crypto? Why decentralization? Why everything? So, even outside the context of crypto, things of value in the world are increasingly becoming digital. So, this is one sort of interesting chart to look at. So this is the money supply of the euro from 1998 to 2007. And at the top you see your usual sort of M1, M2, M3, and at the bottom, currency in circulation. So what this chart basically says is there are currently 8 trillion at least 8 years ago, there were 8 trillion euros in existence, and only about 600 million of them were physical cash. So, people say, oh, we have Bitcoin now. We now have this revolution of, digital and virtual currencies. Well, guess what? The euro is also 95% a digital virtual currency. So it's been happening for 20 years. Now, we also, thanks to the internet, we have assets, even digital assets that have sort of no intrinsic backing by anything physical in the real world, that are already being sold for millions of dollars. So the first major kind of self-backing asset class, the one that kind of people sort of don't think is in the same category but, as something like Bitcoin in the economic sense, but it is domain names. So, the domains for websites like, 360.com, privatejet.com, funds.com, hotels.com, whatever else people are selling for $5 to $40 million. This stuff is literally, privatejet.com is literally more expensive than a private jet. And, this is getting somewhere. So, even things that we do not traditionally think of as being financial assets are increasingly looking more and more like them. Here's an interesting example. So about 10 years ago, there was this college student who decided, hey, I'd like to, actually try to go through college without ending up tens of thousands of dollars in debt, just like everyone else. So I'm going to start a website. I'm just going to start a website, create 1 million pixels, with just an image, 1,000 by 1,000, and I'm going to sell each of those pixels for $1. And guess what? He did it, and he managed to sell the entire website, and he's a millionaire now. So, next time someone says making money is hard, here's another interesting one. So, top 5 instances of some kind of crowdsourced project funding, crowdfund, crowdsale, whatever you want to call it in the world. So, now, of course, I am the founder of number 4 there, Ethereum, but the point here isn't actually to sort of use the Wikipedia page as an example of how great Ethereum is. The point is actually something completely different. So, out of these 5 projects, 3 of them sold, plain old physical items, the sort of stuff that, if someone from the Roman Empire were suddenly sort of teleported in, he'd be able to at least understand why people would want to pay for it. Of course, you'd want to pay for something that gives you time 100 times more accurate than a sundial on your hand. That's like, cool, it's new technology. But number 4 sold 60 million digital tokens whose value is to pay for computational cycles in a decentralized computer network. It's not selling the computers, it's not even providing anything in the network. It's selling tokens that Party A uses to pay Party B, both of whom are just people anywhere in the community. And in order to gain this completely digital resource of having the right to send transactions inside of the Ethereum network that perform computations. Number 1 is even more fun. $90 million, the last time I checked, which is a few hours ago, it's up to 99 million, sold virtual spaceships in their online game for $500. So this is our world, this is the 21st century. Now what's the problem? So, our systems for dealing with these assets, they're often insecure, they're not interoperable, they lack global usability, and they're outdated. That's basically the problem statement. And this is the problem statement expressed in a set of screenshots of recent news articles. Passwords get reset. Major certificate authorities get hacked by random people from Iran. Customer details get stolen all the time. So, how can blockchains help? So, this is the sort of story that we usually hear, this idea of blockchains as a trust machine. So, the idea is that blockchains kind of allow for running application logic on a completely trustworthy platform. So they allow you to build systems that are, that are basically more trustworthy than any single participant in the ecosystem in which they exist. None of us can be as reliable and as trustworthy as all of us together. So that gives you a strong guarantee that the platform will not arbitrarily change its functionality. It's not going to sort of start extracting monopoly rents. It's not going to bait and switch you. It's not going to, increase its prices from $13 to $750 because it feels like it. It's not going to shut down. Not shutting down is actually important. There was a study done a few years ago that shows that if you look through all of the Supreme Court rulings and you look through the websites that the Supreme Court rulings cite, about 49% of them are just no longer accessible because the websites shut down. So, this is one of those sort of benefits of decentralization people don't often think about, but it's there. So, blockchains, what they basically give you is through not relying on any one particular party using these kinds of protocols, they give you disintermediation. So, they give you this sort of generalized X without the X. So, if you like the idea of, Uber, if you like the idea of, just anyone being able to rent out their car, whether they want it to be a full-time job or whether they want to just do 30 minutes of it while they go home from work or just during their spare time, or if you like the idea of people renting out spare space on Airbnb, if you like whatever other sort of sharing economy applications, but you don't like the idea of a company sitting there in the middle and taking a huge chunk of the profits and sort of having a large degree of control over the whole process, then you could create sort of decentralized systems that act as alternatives. So now, of course, when people talk about blockchains as systems for creating these kind of trusted applications, you often end up running into one problem, which is when you start talking to people who are not ideological anarchists, then guess what? They trust Microsoft, they trust Google, they trust their government. So, blockchains are not in the near term going to be competing with these people. Now, of course, that doesn't mean that they don't have value. So one very simple simple example. Let's say you're an American. You probably trust the American government. On the other hand, well, okay, that's a bad one. Suppose you're, okay, suppose that you are an Australian. You trust the Australian government, but, maybe, but you don't trust the Chinese government. Meanwhile, if you're in China, chances are you might not trust any of these other governments. Now, what if you're trying to make some kind of business, and that business involves people in China, people in the US, people in Australia, and a few other countries, potentially if, maybe a few in the Middle East, we'll add one in North Korea for fun. So, in those cases, all of a sudden, you start to realize that once you have this sort of web of international dependencies, maybe it's actually harder than we think to come up with centralized parties for everyone to agree on. So, there are places where this stuff is useful. You just have to think just a bit harder in order to figure out what they are. This is another way of looking at it. So, now, it's interesting actually that, when I mentioned the idea of trusting governments, I got a whole bunch of laughter, but Google and Microsoft seem to be uncontroversial. So, as much as the banners outside criticize capitalism, people's actual reactions seem to be slightly different in some cases. But anyway, so Microsoft and Google, just to play it safe, they seem to have gotten to being fairly trusted, and basically, the reason why that's the case is because they're extremely big, and they spend billions of dollars getting to where they are, and they know that if they screw up, they're going to basically lose potentially billions of dollars of future revenue and customer value and so forth. And so there's this really huge amount of sort of combined economic and social capital institutions like those. Now, if I am some random, 16-year-old living in my mother's basement, and I decide I want to be an entrepreneur and I want to create a financial system. I don't have that. People are going to say, well, okay, it's just some random kid, why isn't he just going to get bored the next week and I'm just going to lose all my money? So the problem is that this sort of centralized approach to getting trust, it does, sometimes and very often work, but it does have it's expensive. It's not particularly accessible for the ordinary person to create an application which is trusted in this way. So one of the potentially value propositions of decentralization is this idea that you can get to trust faster. So, theoretically, it's always possible to get trust the institutional route. But if that route is not available to you, either because you're a 15-year-old kid in his mother's basement, or because you're an entrepreneur somewhere in Africa, or because you're in some industry where whatever kinds of issues just make it harder for large institutions to emerge, potentially some kind of hyper-specialized industry, then you have this alternative route, and you have this alternative approach which lets you create applications that are trustworthy without having to prove to everyone that you're trustworthy yourself. And that's potentially powerful. Aside from that, there's also some side benefits. So blockchains provide platforms that are standardized. They provide platforms that are automated. So for example, if you look at banks are very interested in smart contracts, and as a result, some of them often end up being interested in blockchains. But the part that a lot of these institutions are more interested in is quite often the automation more so than the decentralization. And yet, blockchains are an automated platform, just by their computational nature, and so there's lots of different groups that just end up appreciating that. So, global, you can use a blockchain from any country. You can send money from Kyrgyzstan to Guatemala using Bitcoin, and it costs you exactly as much as sending money to your neighbor, which is great, and surprisingly enough, cheap. So, even though it seems as though blockchains just are this, at least right now, are this horrendously inefficient approach that relies on these, these systems of like thousands or tens of thousands of computers verifying every transaction and mining and so forth. Even still, sending a transaction costs you 3 cents, and sending money through PayPal costs you anywhere from 5 cents to thousands of dollars, depending on how big the transaction is. And even though that fact is more a result of market failure than it is a result of any kind of technological limitations, it's still a fact, and people are interested in blockchains as a way of making things cheaper to get around those issues. Here's an interesting one. Inter-application interoperability that is even more reliable than the platform the applications run on. So this is a kind of counterintuitive, sort of in the same way that if anyone still remembers physics class and somehow managed to cover the concept of sailing downwind faster than the wind. It's kind of counterintuitive in that sense, because if you have application A on one blockchain and application B on the other blockchain, or sorry, on the same blockchain, then even if that blockchain ends up having some kind of hiccup for some period of time, whether it's because of some kind of software glitch, whether it's because of someone attacking it, or anything in that category, even still, from the point of view of within the blockchain's universe, application A and application B can still perfectly talk to each other. So, that's just one of the kinds of guarantees that you could get from these kind of systems. Now, what do people use them for? 3 years ago, this list basically had one item, which is money. Now, the list looks like this. You have generalized identity management. So this is, the idea that people have, for 10 or 20 years, been frustrated with this concept that, you have to have some kind of, 400 different accounts, one account with every forum that you're on, memorize a whole bunch of different passwords, either forget all of them, or, have all of them controlled by LastPass, and then LastPass controls your online life. Or, lately people have been creating applications where if you forget your password, you can reset it with your email account, and then Google controls your online life. So, people want a kind of alternative that gives users more control over sort of their own, online destiny. Reputation systems. So if you're an Uber driver and someday you decide, I don't like what Uber's doing, I want to switch to Lyft instead, well, guess what? All your reputation basically goes back to zero. And it's basically the same thing for any kind of sort of peer-to-peer economy application. So can we create reputation systems that are independent from any one particular company that's running whatever service that people are using at one particular time? Digital asset management, ranging everywhere from currencies to financial securities to merchant rewards points to domain names to whatever else. Securities trading, trade finance, private markets, various kinds of quasi-financial assets. The list goes on, and we're hearing about some new category of application every 1 or 2 months. So, this is just another sign. The space has made quite a lot of progress, I think, and especially in the last 2 years. So, for many of these applications, one sort of, I guess, controversial claim that you can make is that the side benefits are standardization, globalization, are actually even more important than the trust component directly. But even still, the trust component is important because a lot of these other benefits are a natural consequence of it. So, quick experiment with everyone. This was a sort of thought experiment that's introduced by David Friedman, which is based on another thing which is introduced by Thomas Schelling. But basically, suppose that you and another prisoner in another room are both given this list of numbers. And you're basically told, both of you separately pick a number. If both of you pick the same number, you go free. Otherwise, you both die a painful death. So just to make this presentation more fun, actually, let's do this. Everyone close your eyes. And I'm gonna go through these numbers one by one and raise your hand for each one if that's the number you pick. Okay, eyes closed. 942, 1182, 1161, 661, 920, 207, 167, 1000, 1478, 2035, 181, 573. Okay, so there's lots of people are dying painful deaths tonight. Now, as it turns out, lots of people did put their hands up for 942 and 1000, which is interesting. Now, of course, the question is, why would people put their numbers up for, or why would people put their hands up for those numbers? And the answer basically is because they expect everyone else to. And, because in this particular contrived setting, and as it turns out in many other places in real life, if you pick the same thing that other people are getting, you are picking, you benefit. Now, why 1000 and why not 1478? Well, neither number is sort of intrinsically better than the other, and there's no real advantage to picking one versus the other. But it just so happens that within the context of our culture, we use base 10, and so 1000 is sort of artificially made to be significant. And just because everyone knows that, and everyone knows that everyone knows that, and everyone knows that everyone knows that, and so on to the power of infinity, 1000 seems like a good number to choose. And 942, it seems like 942 is the first. That's actually kind of unexpected. When David Friedman actually came up with the example, he predicted that everyone would pick the number that's a power of 10, but I guess he's been slightly empirically disproven on that front. So the problem isn't just, this isn't just a sort of hypothetical scenario involving prisoners. It also happens in the real world. So this is a somewhat famous XKCD comic about standardization. There are 14 competing standards. That's ridiculous. We should come up with a universal standard that covers everything. Okay, now we have 15 standards. So coordination is important. Standardization is one aspect of coordination. So what could you coordinate on? One kind of coordination is different individuals, companies, and governments using the same platform. Another kind of coordination is different applications using the same platform. Another kind of coordination, and something which doesn't really seem like coordination if you haven't thought about it too hard, but actually is different employees inside of a sort of highly bureaucratic organization that's potentially resistant to change, all making a political push at the same time to finally get rid of their 50-year-old systems written in COBOL and replace them with something more modern. So that's coordination too. You know, if one guy does it, he's going to get laughed out of the room. If all the developers do it, then it might actually happen. So blockchains seem to have these properties that naturally, you know, make them good points for coordination. So part, I think, of the reason why people are, people are interested all of a sudden in, blockchains for identity, blockchains for, improving certificate authorities, blockchains for web of trust, and so forth, is that, everyone has known for 10 to 20 years that that the sort of security infrastructure around SSL is terrible, and it sort of combines the worst aspects of centralization and decentralization. Basically, you have lots of security authorities. If you hack any of them, then large parts of the internet are screwed. But people have also known for a long time that these problems around identity management are serious problems. But there hasn't been sort of enough momentum to fix them. All of a sudden now you have this extra ingredient of these kind of neutral platforms called blockchains, and they have somehow managed to sort of successfully stir up the energy, I think, in a lot of communities and actually looking at all of these problems and kind of solving them at the same time. And basically, sort of creating a more secure internet for tomorrow. So, why have blockchains achieved this? Why not credit default swaps or, the self-driving cars or, whatever other things people have invented in the last 10 years? Reliability. So if you're going to build an application on top of something, you need to be really sure that it's going to survive, that if the world becomes dependent on it, it's not going to start charging monopoly rents. Perceived neutrality, and basically sort of a feeling of independence of any single commercial or political entity. Now, note that none of these three are decentralization explicitly. So here's another sort of counterintuitive point. Now, on the left side, you see a picture. This is a picture from the Hong Kong Scaling Bitcoin Conference. This was a panel on mining, and this went around Twitter a lot because if you look at the panel on mining, the sort of headline that came with it is here on stage we have people representing 90% of the mining power of Bitcoin. Now, the 9 people on the right are the Bank of England Monetary Policy Committee. So if you look at these two pictures, which of these two is more decentralized? So, perhaps perhaps it's some sense of perceived neutrality that actually matters, or perhaps you could argue that the miners actually are more decentralized, and you could have sort of these long debates and arguments about what the concept of decentralization and what the concept of control actually means. So, over here you have 9 people from the exact same culture, exact same place, similar social standings in the UK. Here you have some people from China and some people from the West, and they probably don't talk to each other that often. So maybe that is an improvement. So then, but even if that wasn't true, even if the two were equally decentralized, even still, I'd argue that the perception of political neutrality still makes it easier to coordinate, and so even still it's useful. So blockchains are sometimes about laziness. So this is something that I think is underappreciated by a lot of people. So one example for why is, let's say this is an application that only came out, I think maybe about 1 or 2 days ago. This is basically just a very simple app, not particularly impressive. People have done it before. Decentralized Twitter in this particular case on top of Ethereum, but it doesn't really matter which blockchain it is. So people can send their messages get thrown onto the blockchain, and there you go. So if you look, on the surface, if you sort of analyze this technically, once again, it's this thing that's kind of extremely inefficient because, these are just Twitter messages. The world is not going to end if, one of the Twitter messages gets double spent and people suddenly, sort of forget which order the messages came in, or people aren't even going to get that upset if someone manages to delete a message that they sent. But even still, it's being run on a network where the blockchain is being processed by thousands of nodes around the world. But as it turns out, computers have gotten a trillion times better in the last 40 years, and so even with all of the inefficiencies, sending one tweet on this particular network costs about 0.4 cents. So, to some extent, when we're living in a world where computational costs have declined by a factor of a trillion, and human costs, and those even include the human cost of having the conversation to decide, which platform to build something on. They have kind of decreased because, you don't have to meet up in person and you can talk over Skype, but they definitely haven't reduced by a factor of a trillion. So at some point, and, given that this trend is only going to continue, all of these sort of inefficiencies on a computational level are just going to become less significant, and we're going to be fine with accepting it, basically in order to save developer time. So in this case, developer time being the fact that developers could just sort of publish onto a platform, and they could just kind of understand that the entire world will be able to see everything on that platform forever. They don't need to care about uptime. They don't need to care about their own computers. They don't really need to sort of care about much of everything. Blockchain just does it all for them. So that's not a bad thing. Many innovations in software are also about laziness. One example, programming languages. So, you can have code in a high-level programming language, or you can have code in a low-level programming language. And of course, if you actually sort of start editing the low-level programming language yourself, then you can get faster programs. But guess what? Nobody wants to actually do that. Computers have gotten a trillion times better in the last 40 years. Humans have not really gotten that much better in the last 40 years at all. So, with blockchains, developers are free to not even think about what computers are actually running the application, who controls them, what to do if they change the terms of service, what to do if they go bankrupt. You don't have, from a financial industry perspective, you don't have to even think about counterparty risk, because if you have transactions that are being done on the blockchain using counterparty risk-free assets directly, then these sort of entire sources of sort of having to think about complexity that just sort of completely fall away. Don't need to think about what jurisdiction the code is running in, completely global platform. So, this does sort of free up people's minds. So, one way to think about it is, blockchains allow for the creation of software architectures which are politically decentralized. So this basically means you don't have, Uber or Facebook in the middle controlling anything or everything. They're architecturally decentralized. The workload is spread out between different computers, and so this makes them highly resistant to sort of natural failures. But they're logically centralized. So what do I mean by blockchains being logically centralized? Basically, I mean this. So how many people have seen Merkle trees before? So, perfect. So one thing you might notice about a Merkle tree is that the Merkle tree has a root. Now, let's suppose that you were some person, from some tribe somewhere in Polynesia, and you saw this picture you saw two images. One of them was this picture of a Merkle tree. Another one was a picture of of the organizational structure of a corporation that has, CEO, CFO, CTO, employee, janitor. You're going to think, wow, these two things are really, really similar. Now, so my argument here is that, fact is that blockchains, all the data structures that are used in blockchains, everywhere from everything from the Merkle tree to the, to the state, to the idea that there is a single source of authoritative truth, those things are valuable. And as much as sort of concept of things being decentralized and distributed sound warm and fuzzy, things being sort of very sort of clear, centralized, one single source of truth just makes it easier to think about things. And for developers, that's great. So with blockchains, interestingly enough, we have this technology that gives you the best of both worlds. So we get this system which gives you the technological and political benefits of decentralization. But at the same time, it still sort of pretends to be a single computer, and it still lets you keep thinking in the way that you know and love. So what's going to happen in the future? So first half of the problem, technology. So blockchains have problems. Bottom layer, scalability is a huge concern. You know, if you ever go to blockchain tech conferences, you'll probably hear people talk about scalability a lot. If you go to Ethereum conferences, you'll hear people talk about scalability a lot because I happen to think that scalability is an incredibly huge problem. Privacy, also a very huge problem. So, you know, there's lots of companies, lots of banks, they hear about blockchains, they say, ooh, yay, trust, this sounds cool, I'm excited. Wait, so I have to publish all of my customers' data onto a public database which can be read by absolutely everyone, including my competitors. Let me talk to my lawyers about that. So, you know, coming up with ways that sort of to combine blockchains with stronger guarantees of privacy is important. Speed. So, you know, users are used to systems that basically provide you, confirmations within 1 to 2 seconds. Blockchains take anywhere from 15 seconds to 10 minutes. Is that a problem? Can we mitigate it? Should we, what strategy should we use to mitigate it? Middle layer, ease of development. Application layer, you have application-specific issues. Now, 3 years, I put price volatility up there. 3 years ago, I would have, I probably would have put price volatility in sort of in the same section as, things like scalability. And the reason was that back then it was kind of understood and kind of obvious that, blockchains are about money. And now, people are kind of realizing that sort of money is only one application. And even if you have, token-like valuable things on a blockchain, you actually have a lot of, if you're the developer, you can choose. You can choose what the monetary policy of your blockchain-based cryptocurrency is. Could be something based on a fixed supply, could be based on, Keynesian economics, could be based on NGDP targeting, could be based on some kind of system based on community voting, whatever it is, you have the choice. The point of doing it on blockchains is whatever the choice the developer makes, that choice is transparent, and everyone else kind of knows what choice was made, and it's made extremely clear to them before they make the decision to join the particular community. So, for at least, for the bottom level issues, there are solutions. There's a bunch of incredibly cool technology that people are working on. And, if anyone wants to find out more about any of this, feel free to ask me. In my opinion, it's all really cool. Just look at it. It's a diagram. It looks really cool. There's also stuff that people are working on sort of every level of the ecosystem. So, people are working on sort of better protocols at the bottom. Then on top of that, people are building sort of extremely important sort of middleware systems. So smart contract oracles, these sort of entities that publish data into blockchains in order for smart contracts to be able to use them. That's also important, and people are starting to come up with them. People are starting to create them. Reputation systems, identity layers, interfaces, and applications on top of them, and they're all kind of being developed at the same time, and it's all happening, and I think it's only going to get better. So, the way that I kind of see this happening, see things going in about 5 years is, basically something like a decentralized operating system. So, in general, an operating system is basically, the definition is it's this piece of software that sits in between applications and whatever the applications are running on. And the point of the operating system is basically to make it easier for programmers to be lazy. So, programmers don't have to sort of themselves understand what scheduling is, what kind of CPU they're running on or anything similar. Operating system handles all that and provides a sort of, generalized platform, and people can just write apps on top of it, and it works fine. And regular developers can actually manage the code without 30 years of experience. So, for the decentralized web, I think something like that, some kind of unified system that sort of combines together the benefits of blockchains, the benefits of all these other kind of cryptographic technologies, including things like IPFS, some of these sort of more semi-centralized approaches, and makes it very easy to build things that use any of them. And I think at some point, within the next half decade to decade, something that kind of looks vaguely like things like this will probably come together. It might not even come together in the form of sort of a single product that's made by single companies. So the DOS here is not necessarily going to look like the DOS here. But I think this is roughly what we're going towards. So, basically implement a vision for the internet that has security, user control over their own identity. I would even argue, privacy, accessibility, global accessibility, built right in from the start. So, adoption. So, where are we right now? So, Bitcoin has, by global standards, small but stable user base. Bitcoin is the first app, and it is sort of the one that's still the closest to really getting lots of people using it. But all these other blockchain applications, things around identity, things around Internet of Things, different kinds of financial systems, some decentralized governance applications, they're all gaining traction, and I do think that they're all, that there's rapidly growing interest in them. 1 to 2 years ago, people weren't really substantially talking about any of this. Now all of a sudden everyone is. So I think the actual building is not going to take that long to catch up. There's a growing understanding, I think, that blockchains are not sort of about cryptocurrency, and even to the extent that there's a sort of very large range of latitude about what kinds of cryptocurrencies to even more strongly underscore the points, people are saying, what kinds of tokens. They don't even need to be economically similar to currencies in some respects. And, and cryptocurrencies are, very often the means in public blockchains. They're sort of important to security and incentivization, but they're not even close to the only end. So where are we gonna go further? So making the tech better, direct consumer adoption, so people building apps that people actually use, and institutional adoption. So there's banks, there's a lot of non-financial firms that are interested. There's cloud computing providers. There's governments, electronic ID programs. There's lots of different groups that I think are starting to kind of realize the benefits of at the very least of looking at what all these technologies can do for them, and potentially what they can do for the ecosystems around the technologies. So what is it going to look like? So one of the ways that sort of Silicon Valley likes to look at the size of companies is just a sort of really numerical approach. Look, you got 1 million users here, then 5 million, then 30 million. With blockchains, I think it's going to be a bit harder to say. So one of the problems that I think we're going to see is it's very likely that at some point in the next 1 to 2 years, what's going to happen is there's going to be some major bank, and that major bank is going to be working in collaboration with some blockchain startup that just the sort that's probably getting some kind of flashy seed or Series A funding round right now, and they're going to deliver they're going to do some blockchain integration into some product, and of course this is a major bank. They have 500 million customers around the world, and so this startup is now going to blare as loudly as they can over CoinDesk, Wall Street Journal, Forbes, or whatever. Hey guys, we have brought blockchain to 500 million people, and they are using it now. Of course, in reality, the blockchain is only going to be some tiny 1% of what this particular product actually does. So if you're only doing a very tiny piece, reaching 500 million people is not nearly as hard as it is if you're trying to actually sort of take over 500 million people's online lives. And from there, we're just sort of going to grow, and it's going to be kind of sort of harder and sort of fuzzier to figure out exactly how much impact the technology has been having, I think. So, there's a large sort of range in between being a small part of some tiny application and sort of being everywhere. And that's, I think, going to be harder to measure. Several stages may take over a decade. Also a bit of dispersion, I think, in the community. So blockchains, I think they are a tool, and they're part of this sort of tool basket that I'm calling Crypto 2.0. But they don't need to be this sort of single point of focus. So right now, people are sort of using the word as a buzzword. It's like, blockchain, it will revolutionize everything, save the world. And well, so first of all, it's entirely likely that they'll end up being part of a toolkit that revolutionizes the world. Just like SQL was part of a toolkit that's revolutionized the world. But it's I think at some point I think it is sort of going to become people are going to get used to it essentially. Controversial claim: blockchains have no killer app. So this is one that I kind of like to make just because it's controversial and makes people angry, and that means that it's great, and I should like talk about it more. So here's my argument. So blockchains are fundamentally a technology for cutting barriers to entry. So if any single industry is really valuable, if any single industry has billions of users, trillions of dollars of value sitting on it, then centralized institutions probably have moderately good solutions already. And the incentives for coming up with good solutions are just very large. So I think that what's going to happen instead is I think that the benefits of the technology are going to be more distributed basically across thousands of different classes of applications, all of which are underserved right now. And the reason why they're underserved is because they're not quite big enough for the kinds of solutions that we have today to start really caring about them. So I think the largest gains are going to come in areas which are sort of underserved for a few reasons. One of them is sort of extreme specialization. So this basically is the long tail. So international cross-border trading of vintage cars. Nobody really wants to sort of come up with a proper trusted banking product for it. And so you have trusted intermediaries. They take 3 to 6% transaction fees. Guess what? You can replace the whole thing with smart. If you do it right, you can replace the whole thing with smart contracts, knock the fees down probably by 90 to 99%. And of course, this is one example, and there's probably tens of thousands of them. Legal issues, internationality. So what if you actually have 5 people, they want to start a company. One of them is in Australia, one's in China, one's in the US, one's in Iran, and one's in North Korea. Conventional legal systems are going to have a bit of a hard time sort of adjudicating potential disputes in that case. Maybe some kind of dispute resolution system, based on crypto can do better. Small scale. So what if you have some kind of machine-to-machine micropayment economy and you want to have sort of some kind of system for adjudicating disputes that have a size of, let's say, $5, $10, 5 cents, potentially even smaller. So in that case, traditional legal systems might be too expensive, and so something based on smart contracts, might just naturally be a good fit. So what does all of this mean? So first of all, making the underlying technology better, I think, is important. So things like scalability and privacy, they're serious challenges, and there probably are sort of very many kinds of applications that are just sort of lurking behind the corner. And these sort of very few problems that we have right now are probably just on the edge, and they're kind of pushing them back from being used. But if the problems get solved, then those applications will probably get implemented, and the entire world will benefit, and we'll be really happy. One area where privacy is important, for example, is healthcare. So we're seeing, I at least have been seeing sort of lots of people come in and basically, get excited about this idea of, using blockchains to revolutionize health data tracking, because right now we have all of these proprietary silos and it's not really benefiting anyone. But the problem is, of course, do you really want to put the information of, let's say, what prescriptions you have up on a public database that can be seen by everyone, including your competitors? So if there's coming up with sort of strategies that combine the transparency benefits of putting things on public databases with the privacy benefits of of essentially keeping it to yourself, or at least keeping it encrypted in some form that only you can see, that's, I think, an important challenge. The best sign of success is interest from the outside. So over the past 6 years, we've had lots of instances of crazy people basically saying, hey, look, I like blockchains, and here is a problem. Let me use blockchains to fix the problem. Without particularly thinking of whether or not the solution actually makes any sense. So sometimes, of course, those kinds of approaches are going to work, but not always. The other kind of approach that might sometimes work that might often work better is, let's say you have someone who's very sort of passionate and interested about something. So let's say, I don't know, empowering people in the third world through microfinance. And they discover this technology, and they see, okay, this technology seems like it might actually benefit empowering, people in the third world through microfinance. And they themselves voluntarily start using it. So that kind of adoption is, I think, the kind that we should sort of really be the most excited about. And one thing that means is that collaboration with other industries, other movements, other categories of projects is important. So, this is I'm definitely happy that, the peer-to-peer foundation seems like we're getting more interested here because, it's an organization that existed long before a lot of this was invented. And, if we manage to convince you that this has potential, then that's a good sign. Another couple interesting examples. So there's a singer in the UK, her name is Imogen Heap, who has been sort of very excited about this idea of kind of revolutionizing the music industry, coming up with platforms where artists themselves have much more control about how they share the revenue from the songs that they're producing. And so, she was working on the project called Mycelia, which is trying to kind of create a blockchain-based platform for artists to sell music and share revenue in this kind of model. And she discovered blockchains less than a year ago, and Mycelia seems to be moving forward right now, and blockchain seems to be part of a story, and that's great. Providence, another project. So this was basically a project that's existed, even before they've heard about blockchains, trying to help people determine sort of basically, whether or not the original use case was helping people to determine whether or not the products that they're buying, satisfy certain ethical standards. So, for example, is this product made according to good labor standards? Was slavery involved anywhere? Is it environmentally friendly? Was it made in such a way that I know the quality is reliable? And so they discovered blockchains, and they realized that blockchains are actually an interesting technology that would actually help them move this forward. And so they're working with blockchains, and that's great. So basically, conclusion is keep an open mind. There's lots of stuff out there for you. Thank you.